The next step on this example is just to create the logistic regression model. So let me show again the training data set and the variables that we have ready for analysis, and that is the exited flag is our response variable, so it's a binary response. So for that reason, logistic regression is a candidate model to use. And then we have some other variables related to the credit worthiness of the customer, geography, gender, age, tenure, balance, and some other important information. For now, let's take just a few variables to illustrate what logistic regression does. So let's take the credit score, the gender, and the age. And let's create a model just using these three predictors to illustrate what logistic regression is about. So let's call our model logreg, and that is the object where everything will be stored. And to do a logistic regression, we're going to call the GLM function and just use a formula just as we did before with regular regression. And we can use the exited flag as our response, and then we would have, because we want to select the variables, we would have to write them one by one. If not, we would just use a dot, and that should be enough to select every variable. So in that case, let's write the credit score. We want the second variable and to be the gender, and the third variable that we want to use is the tenure in the bank, and that's the number of months in the bank. We want to set the data set to Shorn train, so we are going to basically train our model in the training data set. And the last thing that we want to do is that we want to set the family to binomial. So what that does is that it ensures that we use a logistic regression model. Right, just as before, we can look at the summary of the model, and that should be enough. Just before doing that, let's change the options. And let's change the scientific penalty to 999 so that we get a lot more decimal values. And let's look at the summary now. All right, so we have three variables. The three appear to be significant at a 5% alpha level. So just as before, we would look at the significance of the particular variables, and we will talk more about the null deviance and the residual deviance and how they explain the goodness of fit of the model. But for now, let's focus on the individual variables and the interpretation of the model. So we have a y-intercept, a slope parameter for each one of the predictor variables, and then we have each one of these parameter estimates. Let's first do a few examples of predictions with these models so we understand what the logistic regression formula does. All right, so let's first set B0, and again, I'm just doing that. You can use any calculator to do that. So let's set B0 to that. B1 is our slope for variable 1. B2 is our slope for gender, the male. And we have B3, the slope for tenure. All of these slopes being negative, that means that as the credit score increases, that decreases the log odds of churning, of dropping, of stopping being a customer from the bank by 0.001 on average. So again, let me explain the interpretation piece. So we would say as credit score increases by 1, the log odds of churning from the bank decrease by 0.001 on average. Now, the problem with this interpretation is that it does not, it is not so easily understood. When we talk about the log odds of churning decrease, it is not something that an executive would probably understand very easily. So sometimes we would prefer to look at the odds as opposed to looking at the log odds in terms of interpretation. So one thing we could do is raise this value to the e power, and we can do see exactly what that value is. And just remember that in order to get the opposite of the log, which means the when we want to take out the log function, we would change the other values to be the exponential. So when we get this gives us a 0.9987. So the interpretation that we get is as credit score increases by 1, the odds of churning change. So we have to use this wording here, change, by a factor of this, which is 0.99. Now, when you change by a factor of that, that really means that we are decreasing the odds. So let me put it this way. When you change by a factor of 1, there is no change at all. So if you multiply the odds by 1, it's just the same odds. If you multiply the odds by 0.99, that decreases the odds of churning. So it's not really that it increases or decreases, but just changes by multiplying whatever odds you have by this factor. Okay, so if we want to look at it in terms of percentages, what we could do is take this value and basically subtract 1, so that would basically give us a percentage-wise by how much the odds would decrease. So we would say something like as credit score increases by 1, the odds of churning decrease by about 0.1%. Okay, so that's another way to interpret these parameter coefficients.